Cement, as you can relate to while constructing homes. Mason lays the bricks, puts some cement on that, and then lays another layer of bricks. With time, after the curing process, the bricks get stuck to each other permanently with good strength. But from where does this cement come from? First time the world came across this word in 1824. Cement was first developed by Joseph Aspdin in his kitchen. An enterprising 19th century British stonemason heated a mix of ground limestone and clay in his kitchen stove until the mixture calcined and finally grinding it into a fine powder. The result was the world's first hydraulic cement, one that hardens when water is added. Today, cement industry is one of the largest industries of the world. It ranks next to steel in construction material and so is the basis of all modern construction. It is the same material that is cursed the most for the cause of environment deterioration. The high temperature needs and huge carbon emissions make it environment unfriendly. But before we curse the process, let's understand how cement is produced these days.
Cement is produced in cement factories by taking material from the earth, various carbonates, silicates, whatever, depending on the type of cement, and then processing it at very high temperatures, greater than 900, sometimes even 1000, about 2000 degrees C, and so on, depending on the type of cement, and then processing it, grinding it, mixing it. So it's an energy intensive process. And in addition to that, it is environment unfriendly because that process emits a lot of carbon dioxide. The carbon dioxide emitted by the cement plants across the world is more than the carbon dioxide emitted by all the planes plus all the ships put together. That's why it becomes environment unfriendly to a large extent.
But we need cement for construction. Then what to do? Here comes the savior in the name of biocement. Biocement synthesis is more energy efficient as it requires temperatures in the range of 30 to 40 degrees Celsius, whereas conventional cement production requires above 900 degrees Celsius. Biocement is eco-friendly because it has negligible carbon dioxide emission, whereas conventional cement production is a significant contributor of global carbon dioxide emissions. Biocement production can potentially be more economical since industrial wastes can also be used as raw material for the bacteria. Biocement production is faster in comparison. Further research on biocement has shown that it has comparable shear strength, durability, and reduced water absorption capacity and permeability to the conventional cement. The concept is decades old, but it is yet to reach you. Why this is favorable? Experts have the answer.
This process does not need high temperatures. It does not emit as much carbon. It emits very little carbon dioxide, just what the microorganisms put out as a part of their metabolism and so on. So just by these mild conditions and no emission of carbon dioxide, this material gets made. That is the biggest difference.
Bacteria serve the purpose of making cement environment friendly. Not only this, it makes the cement self-healing, and the process is called microbially induced calcite precipitation. This is done in IIT Madras laboratories by the respective researchers. The IIT Madras research team was led by Professor G.K. Suresh Kumar and Dr. Neerav Bhatt, Assistant Professor, both at Department of Biotechnology, with Ms. Subhasri Sridhar, Research Scholar at IIT Madras.
The microbially induced calcite precipitation is something like this. It is from the point of view of cementing things together. What happens is some bacteria under some conditions produce this calcium carbonate around them. They slowly generate calcium carbonate as a part of their metabolism. When they do this, they bind the various things together. Therefore, if these bacteria, under certain inert conditions, they're called spores, they get mixed with normal cement and then they are used. When cracks appear in the cement, that's one of the biggest problems with cement. When cracks appear in the cement and leads to deterioration of properties, the air and water and things like that get through those cracks and reach these spores. That provides appropriate condition for the germination of these spores, as it is called. In other words, to make it into a live form again, the bacteria into a live form again. And once it becomes live, then it produces this calcium carbonate. When it produces this calcium carbonate in the cracks, it cements the cracks. And that way it becomes self-healing. You don't have to do anything else. You just have to use this bacteria to seal the cracks.
Cement that heals itself sounds impossible. But we have the best of the scientists in the world, so anything and everything is possible. But what about the harsh weather conditions in India? How the bacteria will cope up with it? We have a successful example to prove the worth. A demonstration project of self-healing roads was done in a village about 90 km from Bengaluru. The road was constructed in October 2015 and was developed by an alumnus of IIT Delhi named Kumar Bhantia, who is now a professor in the Civil Engineering Department at University of British Columbia in Canada. This self-healing road had to be monitored during the Indian summer and monsoon to make sure it lasted despite extreme weather fluctuations. After long observations, the road has been declared a success. It is expected to remain in best of its condition for 15 to 20 years. No doubt, the concept of biocement has the potential to radically change the construction industry. Then what are we waiting for? New technologies and innovations are constantly emerging to improve the sustainability, strength, and applications of cement and concrete. Hope to adapt to such innovations and bring them to our life soon.